Designer's Cafe.
Over the past 4 weeks, Risk Bites has explored what advanced materials are and why so many people are so excited about them. But what about the downsides? Do new materials automatically come pre-packaged with new risks? Exploring the potential ways new materials can cause harm is important. If you want to make money from advanced materials and the products they're used in, maiming or killing your clientele in the process is not a great business strategy. And surprising as it may seem, many folks in business would rather be improving people's lives than making them worse. But if you've got a brand new, never-before-used material, how do you know what it might do that you probably don't want it to? One approach is to assume the worst. Maybe that novel, never-before-seen nanoparticle, for instance, could burrow into your brain, replicate itself, and bring about the next zombie apocalypse. Maybe it could, but probably it won't. Fortunately, a firm grasp of scientific reality, past experience, and some risk analysis know-how go a long way to helping predict the likely ways a new material might be harmful and how that harm can be avoided. The first thing to ask if you're interested in health risk is, can this new wonder material get into your body? The obvious ways a material can get into your body is through your mouth, or going up your nose, or diffusing through your skin. If there's a way in, we need to consider the harm that could be caused by the material as a result. But if there isn't a way in, there's little chance of harm occurring. For example, a single carbon nanotube could be inhaled or ingested and get into your body that way. But wrap it up in an iPhone, and unless you have some rather odd eating habits, it'll probably stay in the phone and not get into you. But what if an advanced material does get into your body? Over millennia, we've lived in some pretty cruddy environments as humans, and as a result, our bodies have evolved to handle stuff that could be harmful. It's a neat survival trick that has helped us stick around for as long as we have. For many advanced materials, our bodies will process and eliminate them just as effectively as other materials. Just because we think they're fancy doesn't mean our bodies do. But there are some warning signs we've learned to look out for in materials that our bodies don't handle so well. Particles that get into us and don't dissolve or degrade easily aren't great news, for instance. Neither are particles that are long and thin, like fibers, or crystalline, or small enough to slip into places they shouldn't, or materials that release known toxic chemicals. These are all characteristics that scream "watch out" if they're present in a brand new, never-before-tested advanced material. In other words, out of the vast array of advanced materials we could be using, some may need to be handled with special care. But only a small number of these materials will have the potential to get into our bodies and cause harm. Of these, only some will overcome or slip by the body's defenses and cause serious harm. And of these, fewer still will cause harm in ways we weren't expecting. And a very small number of materials indeed will lead to new diseases. As a colleague of mine likes to point out, the body only has a limited number of ways of saying, ouch. By using scientific understanding and expert knowledge, many of the potential risks associated with advanced materials can be spotted and managed, or avoided altogether. That said, there are bound to be unknown unknowns, those things that a newfangled material does that no one thought of beforehand. While second-guessing what these might look like can be a dangerous game, it's important to continue researching possible risks, just so we're not caught with our pants down when something unpleasant does eventually turn up. Next week, Risk Bites will explore the tension between novel behavior and novel risks in more depth. Until then, though, stay safe.